Welcome to School of Civil Engineering. In our previous video, I have shown you that how to analyze our frame, for beam, and by using different types of load. And in this video, I will show you that how to analyze our model, our frame, by using STAAD Pro for point load, for distributed load, and for uniformly varying load. So let's start. As previous, I'll open STAAD Pro, and after that I'll go here. As previous, I'll open STAAD Pro here, and I'll go for new project, and here space foot kilopound. Okay, frame analysis. Then press next, and about that all basic I have discussed in previous, that's why I'm going fast now. So add beam, finish. So I will use that chart. To analyze our frame. Suppose there have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes. I'll use first node and last node, and also I will use the upper node. So 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. Maybe it will be the middle node. So first of all, I will select that node, and I will select also that node, and also I'll select 3 feet top that node, and also I'll select that node. Then I'll go here, snap node beam. Here you can see that we have draw a rectangular portion. Then I'll go here, I'll go click for view from Z plus. Now I'll delete by using beam cursor. I'll delete that beam. Press delete. Yes, delete that beam. Now I will use it as a frame. So for that, I will go for analysis by that frame, and here use select cursor and select that node, and press Ctrl and also select that node, and go here, support page, create support, and from here pinned, use pinned support, and press here assign. So we have use pin. After that, we'll define materials property. So for that, select that beam and Ctrl select that beam. After that, go here materials property, and go here define. So after that, rectangle, it's 1 feet into 1 feet. That's not fact how much we are considering, because it will not consider itself weight. We will do it for the concentrated load. Now I'll click here assigned. So it's have assigned the frame. After that, here I'll go for load page. First of all, I will use a concentrated load on here. So load case detail, select on it and add. from here use, suppose use nothing, none. From here use load. Okay, load case on, add, close that. So from load case 1 click here add, and from here we'll select nodal load. We'll select nodal load, and here support displacement and nodal load, and we'll give value at that node. So we'll put the value in opposite y direction, suppose 10k ky. So for that we'll click here add, and we'll close that. So for -fy, then go to the node cursor and select that node and select that and assign to selected nodes, assign, yes, and click here for loads. It's showing the loads here. Now we have defined everything. Now we'll go for analysis. We'll go for analysis. So here comment analysis, perform analysis, no print. Okay, then we'll go for analysis, run analysis, save. Here 0 warning, 0 error, 1 warning, 1 node. So that's not headache. Warning 0 warning, it means we're unable to use our model. So go to post processing mode, done, load case 1. Okay, here we're seeing that is our model. After that we'll go here, we can see the displacement. For that scroll your mouse, for that click beam cursor and scroll your mouse. They have no displacement, it's showing the little displacement, that's why it's not showing. After that we'll go here reaction. Here we're seeing that as this load are coming at that direction, and it's trying to move in x direction and also y direction. That's why it's showing the load in x direction and y direction, and also here for x direction and y direction. And if we go here axial force, we'll find out the axial force of the frame. After that if we go here for Fy and bending moment, you'll be able to see the bending moment of it. This is the bend, this is the shear force. And after that if we go here torsion, have no torsion. If we go my, so no my, mz. So if we go for mz, here is the moment. Here is the moment diagram for our model. And if we go for deflection, 0.03 inch deflection, it's very low. So this is the deflection of our model. In this way we can analysis for that. Now I will again go for modeling, and I will change the load pattern. Suppose here load base, go load Fy, just I will modify that load, and sorry, close that. I click on it and edit. So I'll just give that load in that node for not Fy, just for Fx. Control, cut that and paste it here. So Fx minus 10 is that direction. So change 0, change, yes, close. It's showing the load in that direction. Now we'll go for analysis, run analysis, save structure. Okay, go for post processing mode. Okay, here here you are showing that it's showing a deflection. It's showing a deflection now. Now we'll go for reaction, and here it's showing reaction for X direction and for X direction, and this is 3 for Y direction upward and this 3 for downward reaction. Here is the way to analyze a frame. So in the next video I'll show you that how we'll analyze that frame for uniformly distributed load or for uniformly varying load. So thank you very much. S12 and stay connected till next.